Hello, welcome everybody. Thank you for joining us. I'll just give everyone a minute or two to join the call and then we will get started. Let us know in the chat where you're joining us from tonight. And I hope the weather isn't too miserable wherever you are. It is particularly miserable in Bristol. Hello, hi everyone. Oh, people from all over the place tonight. Very cool. Croatia is a bit of a sensitive subject for me at the moment. I've just had my holiday cancelled there in September, so we're going to Yorkshire instead in England, which I hear is very similar to Croatia. Okay, cool. Yeah, keep letting us know where you're from in the chat. It's just nice to see everybody, where you're all joining us from. Cool. All right, so we will get going. My name is Laura Swales. I am the What am I? I'm the Events and Community Manager at Mango Solutions, which is now an Ascent company. We were formed in 2002. And like I said, we were acquired by Ascent in 2020. So that's been reasonably new for us. And Ascent have just really made it so much broader, the kind of things that we can now offer. They are experts in software solutions and we are experts in data science and all that kind of stuff. So we've been able to do lots more new and exciting projects. We are based in Chippenham, Bristol and London. We've also got offices in Malta and Bulgaria, which are from the Ascent side of things, which has been really exciting. And yeah, we empower organizations to make informed decisions using data science and advanced analytics. And we also organize a range of data science events, which I'm sure you will all know about as you've joined us here. One of them. Usually we meet in London, somewhere in the middle of the town. We do a workshop, we have 3 presentations, and then best of all, we have networking drinks, which seems to be a big thing that people are missing, and I definitely miss that. So I don't know, we're going to see how things go maybe later on this year for a possibility of an in-person meetup, but we want to make sure that it feels safe and it's the right thing to do. And when we do eventually go back to in-person, I'm really keen that we still offer some sort of online streaming version, so to make it as accessible as possible. And it's been really great to see people joining from all around the world. So we want to definitely keep that going. As the rest of the world is, we are hiring. So take a look at our website for the kind of roles we've got. And I think there's a couple of data scientist, engineering roles. There's a huge variety. So yeah, take a look at our website for that. And EARL, many of you might have heard of EARL before. EARL stands for Enterprise Applications of the R Language Conference. Usually we're in London in September for 3 days. We've got a day of workshops and then 2 conference days. We have about 64 presenters, about 300 people come along in person. And we always have a fantastic evening reception. Some are really interesting, like the Tower of London. This year and last year, we moved things online for obvious reasons. So like I said, we're doing that again this September. We're doing a week worth of EARL events. So Monday to Thursday, we're hosting workshops, which run 2 till 5 o'clock UK time. And we're doing introduction to Shiny, package development in R, functional programming with Per, web scraping and text mining lyrics in R. These workshops are priced at £90 for a half a day. Usually in person, it's £200. So we're able to offer a lot cheaper prices because we just don't have the usual overheads that we do. And then the Friday, which is the 10th of September, we are having a full day of presentations from various people that use R every day with work. We've got people from Land Rover, Capital One, a really interesting mix of industries. We've got someone from the NHS. And we've got Jacqueline Nollis from Saturn Cloud as one of our keynote speakers. So we're really, really excited to have her along. And that Friday session is only $9.99. And we're also really, really pleased to be able to donate the profits again to charity. Last year, we donated our profits to Data for Black Lives. And this year, we're donating them to DataKind UK, which is an organization that helps charities and social change organizations use data science in really cool and interesting ways. And if you're a data scientist, you can volunteer and give them time. So that's who we're donating to this year. So yeah, take a look at earlconf.com for all the different events that we're doing. And if you have any questions, just drop me a message. Very happy to help. And then yeah, LondonR, we have been doing them like every other month, doing workshops and then these evening presentations. So if you'd like to present, please drop me an email at events@mango-solutions.com. I've already got a massive list of people that want to present, but I'm always really, really pleased to hear from people and to put together a good agenda for you all. And then moving on to tonight's agenda, we are starting off with Paulito. Paulito is from IBM Dublin Research Lab, and he'll be presenting on JuliaR for data science and machine learning workflow. Next up, we have Elizabeth Brown, who is a fellow Mango Solutions colleague. And she will be presenting on creating a Shiny dashboard as a tool for learning Git. And then finally, we have Omateo, who will be presenting on business analytics with R. Just to let you know, a few housekeeping things. If you have chat, pop it in the Q&A section. And if you have general chat, say if you're enjoying something, just pop that in the usual chat. There is a slight delay between me speaking and you hearing it. There's about 8 seconds, so just bear that in mind. And this session is also being recorded, and I'll put it up on YouTube hopefully tomorrow, if not the day after. So yeah, thank you. And if you're enjoying the session, please let us know. #LondonR on Twitter, and we're at Mango the Cat. So I am now going to bring on Paulito and hand over to him.
Hi, everyone. Let me share my screen now.
Great.
Can you see? Okay. So here's the outline of my talk. So I will start with why JuliaR. So when you say JuliaR, it's just Julia and R. And then I'd like to show a COVID data exploration as a kind of use case. And then how do you model with JuliaR? And we will have an example of how to package and do some kind of production for JuliaR. So let's start with why JuliaR. So first is that Julia is a modern language, like 9 years old, to get compared with R, which is a very established language, I think more than 30 years old. So the good thing about this is that Julia has all the the features of the modern language, which, like, for example, supports parallelism, distributed computing, and so on. So let's start with easy interface with R. So for example, I have a data from Julia. I can basically pass this to R by using string interpolation. So inside this code is Julia code, is our R code, and this one says that please pass this, which is because this data is outside R, and then copy back the result. So you have this result. And then you can also put the data to the R in the background, and then you can plot your the data. So you basically, it is seamless to run R inside Julia. And then I can also do a lot of, for example, random forest modeling and run this. And whatever, if you have multiple lines, you can use R triple quote or R string macro, that we call it. And then anything that is inside here is pure R, and you have this result. One good thing about Julia is that it supports parallelism. So for example, I can create several workers, and then I will load rcall, which is the one that allows me to call R to all of these workers. So that's the command at everywhere, means that load this to all workers. And then now I can run, for example, different trials of this random forest that does iris data set, split the data for testing and training and testing, and then accumulate the accuracy, and then copy the result, and then run it, and then return the result. So let's run this. So you have several workers running at the same time. Let me show you the workers that I have. And then after the workers return, it gives you the result of the eval, which is concatenated here. So this is your MapReduce kind of thing. You distribute the entire thing, which is inside here, and then you collect the result, concatenated vertically or in a vector, and then you can get the result and then get the mean of that result. So basically, that's the one thing that I'm gonna use a lot, where you have this R inside, and then you do a lot of distributed computing inside Julia, and you will notice that it's very seamless. And then the reason why I like to use Julia and R, because in certain workflow where you need Julia's speed, I will shift to Julia, and then in a certain workflow where I need a library that is mature enough, then I will use R. So for example, I have a 100 million data set here. If I do a summation function in Julia, it will take me only around 0.3 seconds. If I do this in R, this is exactly our code, I will need 2 seconds. And just imagine if this is a big data set, this differences in second can convert into days or minutes or maybe months, depending on your data. Even in PY also, Julia also seamlessly called PY. If I run this PY call command, sum this function, it will take me 10 seconds. So both Python and R are interpreters. So if you're doing, for example, programming from scratch and you need certain kind of speed, then I think it's no-brainer to use Julia. So Julia is started in 2009. The version now is stable, started in 2018. It was announced in London. And then in 2021, there's now 29 million plus downloads, 200,000 GitHub stars, and 6,000 packages. And the packages are growing, and it can run in Windows, Mac OS, Linux, and FreeBSD. And then for the hardwares, Intel, ARM processors, and PowerPC. And for those who are interested more about Julia, you can actually Google Julia language or Julia lang, and it will give you send you to this link. You can download Julia, and then there's a discourse if you have questions about Julia. And I would like to plug right now, there is a upcoming Julia conference on July 28th. And right now, today, there's a series of workshops. So before July 28th, from I think last week until now, there's a series of workshops. You can go to JuliaCon link here, and then you will see this announcement. You can register for free, and you can attend the workshop. Okay. And then I would like to advertise my repos. So I'm having different kind. I'm maintaining, I think, 4 or 5 packages from Julia, including the AML pipeliner that I will present now. So this is basically JuliaR, but because Julia does not allow to use the word Julia in your package, I have to use the ML pipeliner, which is the ML pipeline is my base package. Okay. So let me now proceed to the presentation. So let's start with the exploration of COVID. So let me load the data, which is taken from this location. So this is your data set. There's a lot of columns, so I will just focus. So let us describe what are these columns. I'm just interested with date, continent, location, new cases, and new deaths to make it simpler. For the sake of that, I have only like 30 minutes of time. So I just, you'll notice that all of these commands here are from the tidyverse. So, and then I copy back to Julia to show it to you. And then I can describe what is this that I've got. So I'm now focusing on the continent, the date, the location, your cases. And these are the minimum and the maximum. So we make sure that the minimum is 0, there's no negative value. That's why I filter here all data sets, new cases, and new deaths to be positive, because it doesn't make sense to have a negative value. And this data set has negative values. I don't know, maybe its noise. And then I will filter the continent of Europe. So you will see here Europe. You can visualize this in a Voyager, which is from Julia. So basically, this is Europe. You can, for example, drag here date. You can drag here the new cases. Sorry, my computer is busy. And then you can drag here the location. Come on. And then you can filter the location, for example, of new cases. So let's clear this screen because we are UK. So let's see what's the cases in UK. So the UK cases is going up, but if you see the deaths are quite flat. So there's no problem with UK, even though the cases are up. And let's see again, new cases. And then so you can filter, for example, here, Spain, what's going on in Spain. You can add here the new deaths in the size to see that here the deaths are still small, right? And then although the cases are high, and so on and so forth. So I will skip now, but basically it allows you the Voyager to explore the data set. Now you can filter United Kingdom and then copy it back, and then you can go back to the Voyager because it's now a smaller data set. You can just focus on United Kingdom. So again, date, new cases, so it's faster now, and new deaths. So you'll see now that the cases are high in 54,000 cases, but the death is just 47. So it's quite okay because I think of vaccination. So after that exploration, you can use now, we can now use, for example, Julia to call R. So we can create plot cases, which is a Julia function, but behind it, embedded to it is just ggplotr. So I make sure the good thing about Julia is that you can restrict your arguments to be data frame and string, country string. So if you passed anything that is not a data frame or anything that is not a country, then this function will not fire. So it's like a function barrier that makes sure that this function will only work if you pass the correct signature. And then let's plot it. So now we're interested, for example, with Ireland. So Ireland case is flat because we have not yet opened. So cases here, deaths is flat. We can see here New Zealand, almost flat. Maximum cases is 80, maximum deaths is 4. We can see Australia also. Cases are getting higher, but death is flat. United States used to be bad, but right now cases are a little bit getting higher, but the deaths are still flat. Germany, still okay, looks okay. Italy looks okay also. The deaths are still flat. So because I think in Europe the vaccination works, but for example in Philippines we don't have much vaccination, so the deaths are around in the 100 average, and the cases are going up. Not going up actually, but still here. China is okay. Russia I think is not good. So if you look at Russia, everything is going up, cases and deaths. Indonesia is also not good. So they are now around 60,000 cases and around 1,200 plus deaths. And it's going up, the trend. The same with Thailand also. So I think Indonesia and Thailand is something that we have to monitor because the cases are rising in Asia. But for European countries, I think because of vaccination, the image is quite okay. Taiwan is also good because they have only like 600 plus cases and deaths are very, very minimal. And Singapore is a good example of a very good, what I call this, statistics. They have a very, very low deaths, like maximum of 2, and cases are very, very low. So now let's go now to the modeling phase. So let's assume that we know something about COVID and we want to predict something. So let me group arrange the data into location, and then for each location, let's get the mean of cases on that location, the deaths, the population, the cardio. So this is just for illustration purposes. So let's summarize them, and then let's see what's going on here. So you have some NANs, So let's do the imputation in R so that we don't have NaNs anymore. And then we copy it back to Julia so that we have the data frames in Julia. And then let's remove the location so that it's not obvious. And then let's use the new debts as the mean of new debts as our target output. So we have all these features except new debts, and the new debts becomes our Y. So let's use our random forest using caret as our model and find out what is the typical RMSE. So the best is around 242, right? So this is our baseline. So if you do random forest in a typical way, we can find out which of the models are important. So new cases is a good predictor, and then the size of the population. The others, like diabetes patients, they're not much. So of course, it makes sense that if you have new cases, the new deaths will also. If you have a bigger new cases, you will have a bigger cases of new deaths also. So it makes sense. And if you have a bigger population, denser population, that also is a predictor of new deaths. Okay, now, so let's create a model using a distributed approach in Julia. So we do this is now the summarization. Oh, wait, yeah. But we're gonna do it by week because we want to predict now every, weekly. So we group by location by week, and then we do the same cases, and then we automatically impute the data so that we have this data. And then we run the modeling here, okay? And then we save the model. So for every country, so we loop over the locations, and we do this in a parallel manner because each location can be modeled separately. And then we use the random forest model, and then we model the data set and then save the model. So we run it. We have several workers running, processing all the countries and modeling it, okay? And then we go to the final result. So these are the list of the models that we have, and we can find out whether which of these models are good or not. So depending on the quality of the data, we can predict weekly the new deaths. So for example, for France, let's see. So for France, we have like 71% of the variable explained, which is not bad. What about United Kingdom? United Kingdom is around 71% also. What about Spain? Oh, Spain is not there. What did I do? Italy. Italy, that model, sorry. Italy is 83%, quite good. What about Spain again? Spain is not good. That means to say that some of the data collection or some of the quality of the data from Spain is not really good. So this is an example of combining Julia and R, and it makes things faster because we do things by distributed computing. Okay, so let's now do a certain kind of example of packaging. So right now I have, let me show you. So I have a ML pipeline package, auto ML pipeline, which is basically a pipeline, what do you call this, pipeline package in Julia, but I will show you later what it does. So again, we try to group by location and then get the cases, the same problem, and we want to predict the death, so it's the same problem. But right now, our base case is that here, again, let's look at the base case. We want to make sure that our pipeline later, the ML pipeline, will be much better than this. So we have 344, which is the best that the random forest does. So in the ML pipeline, we have a series of pipeline stages where you have preprocessor, and then you have the scaler, you have the extractor, and then you have the learners. So this is a pipeline, for example, numerical features pipe to run robust scaling, and then pass to the R regression. And then you fit and transform, and then you can predict the RMSE. So you have the RMSE. You can also do different kinds of transform like roboscaling and then ICA, and then gradient boost, and then cross-validate. So this is the typical machine learning pipeline. So one of these pipelines will be the best. So the question is that, what are the combination of scalars and extractors and learners will give me a better RMSE? Our target is should be better than 345, which is our baseline, which is done by random forest. So what I can do here is that I can loop over the scikit-learn RF, scikit-learn gradient boost, SVR. So right now I am having a scikit-learn package, but I will show you later how to extend these learners using the R random forest. So if you do that, we loop over. So we have workers looking for the different combinations of pipeline using cross-validation, and the result will show you that, wait, where is it? Sorry. Yeah, so here, the result will show you that for all this pipeline, the best is the min-max scalar followed by no operations for the extractor and then random forest regressor. So this is much better, 334, which is better than 345, which is our base case. But what about if we extend this to R? For example, these are all scikit-learn. So what I can do is that this is my pipeline base, and these are my abstract functions, abstract types, and I'm going to extend using caret subtype of learner, and this is the mutable structure. So I create another structure, subtype of learner, and I define fit and transform so that when my pipeline runs, it will call the fit and transform in order to validate the data. So inside this fit is basically your rcall, and inside your transform is rcall. For more information about this, I have other videos and presentation about this. So I will not go into the detail because because of the time constraint. But what we can do now is that we can create a package, and we can do some kind of testing, like testing this package, how so it passes like fit transform, and then the sum of the fit transform is 150, and then if we cross validate, the accuracy score is 0.80. So this is basically your a module, because we created a module here, and then we import the module and run the unit test. So we run the unit test, and then we can plug it to my pipeline base and have the unit testing that now supports R. So now I have R. So this is my pipeline with R. So I can now load this, and then now I can define a random forest from R and call using R, and then run this together with my random forest from R. Where is it? So if I run that, you will see now that my result is still the same, but I have now R from R as a part of this comparison. Again, the best result is still the random forest regressor from Julia, which is 334. But because of the standard deviation that are large, I will suppose that these are all similar results. So you will see now that by adding R, by extending using Julia, what we call this rcall, we can basically embed R running together with Python, with Julia also, and use this to compare the result. So I can actually incorporate other machine learning packages from Caret. There are many of them, and use them for further comparison. By this, I end my presentation. Thank you very much.
Great, thank you, Paulito. If anyone has any questions, feel free to pop them in the Q&A section. While we wait, because there's a little bit of a delay from when we speak to when people hear it, do you just want to remind people when the JuliaR? I'll make sure I'm saying it right. Conference is. Do you just want to remind people when the conference is?
So the Julia conference is on July 28th. It is an online version. Mm-hmm. It's a free registration. So you just Google JuliaCon, 2021, and it will show you the link. And I think there's an Eventbrite that you can register. Then it will give you all the schedule. I have a talk there also with this AutoML pipeline. It's in much detail, so it's really like showing you the step-by-step of how I develop the package and how I approach the what do you call this, the prediction and classification tasks. Because this technique is basically the latest technique in machine learning. We call it auto machine learning, which means that you don't have to worry about the different combinations of the pipeline. The pipeline will be discovered automatically by the program. And there's a lot of them, like auto scikit-learn. There's a genetic approach like Teapot, where it creates a tree and tries to branch out the tree for more pre-processing and so on. And mine is just one of those approaches.
Okay, great. It doesn't look like we've had any questions come in just yet. But if any come in, are you watching the rest of the talks, Paulito?
Yes.
Oh, cool. Yeah, if you do have any questions, feel free to pop them in, and then Paulito can reply to them that way. Oh, there we go. Just as I said that, we got a question. Francois says, "Is it the same thing than AutoML?"
Yeah. So that's the same name, AutoML. Yeah. Auto machine learning. Yeah. Automated machine learning.
Cool. Great. Thank you. Okay, great. Well, thank you so much, Paulito, for joining us and for that great presentation. Thank you very much.
Thank you.
No worries. Okay, so next up we have one of Mango's very own, Elizabeth Brown. So I'm going to bring you on stage now, Elizabeth. Hopefully you'll be able to unmute yourself and share your camera when you're ready.
Can you hear me?
I can.
Can you see me?
I can't see you yet. I can see your screen. Oh, there you are. You've come up now.
Well,
perfect. Right. I will leave it with you then.
Well, thanks, Laura. Hi, everyone. So I'm going to give a presentation about an app that I created using Shiny called Git Shiny, which is a tool for beginners to learn Git. So currently on my screen is the GitHub page for the app. So the GitHub page has Git Shiny, which is the Shiny application that I'm going to give a demonstration for. And there's also a folder called Example Apps, which has a few small example apps that kind of demonstrate different techniques that are used throughout the main app. So first, I'm going to actually launch the app. So I've already kind of downloaded the files onto my RStudio. So then in the console, I can run DevTools load all and give it the name of my app, Git Shiny. And then I can launch the app by running the function run app. I'm actually going to open this up in the browser. So this is the app. So it's a dashboard. On the left-hand side, there are a number of tabs with pages, and that's the content and the materials of the app. So for those of you who might not know, version control is a system that records changes to files over time. It's really useful when collaborating on code, and Git is a version control system which is widely used. Version control is a best practice with software development and also within data science. And this app is designed to be an introduction to the basics of using Git locally on your machine. So the first section of the app has a setup page, and this gives instructions on how to download and install Git Bash. So the materials within the app use Git Bash. So you can scroll down and read different instructions on how to get that installed. I then have a bottom navigation bar with a previous and a next button. So I can also use this to navigate between the pages of the app. If I click next, I go to this second section about working with files. So here we have some information about how to create directories and set working directories, and generally just to get familiar with using the command line, which many people might not know how to use. So this app is designed to be a beginner starter, so assuming no knowledge of Git Bash or the command line. So if we scroll down, we have a exercise box and a solution, which has a little plus icon that I can click and expand the solution. And there's also a tips box. And in this case, it has a tip about tab completion in the command line. So each page kind of follows this outline. So there tends to be an exercise on every page and some useful tips. So the second chapter gives a basic Git workflow. So the user can use these previous and next buttons to move through a workflow. So this technique is used throughout the app to create sort of visualizations that are interactive to help aid with like the learning of the content. So this goes into having local and remote repositories, a working directory in a staging area, and things like git add and git commit, git push, git pull, and git checkout. So this gives an overall kind of workflow of Git. Then chapter 3 contains basic Git commands. So the first section is about tracking changes. So it goes into how to create a local repository and how to add and commit files and changes to files to the repository. So for each part, there's a practical working example. And then at the end, we have an interactive workflow to summarize the example so the user can use that to reinforce the learning. So again, there's another example and another workflow. Here we also have a box about using the Vim text editor and also about best practices for commit messages and why we actually have a staging area. And again, exercises and tips. So we have another section. This section covers amending commits. So that could be commit messages or actually adding files or changes to a commit. After that, we'll go into looking at the command git clean, which allows us to remove untracked files. And then finally, we have a page about reverting changes. So this goes into a command called Git Reverse. So first, there's an interactive workflow, which kind of explains generally how Git Revert works. And then there's a practical example for how to revert back to the most recent commit. So here we have a working example, and then at the end, an exercise to reinforce the idea. And then finally, we have this chapter 4, which is about branching. So the first page is an introduction to branching. So with Git, we can create branches which allow us to work on independent, isolated sort of environments within a project, essentially. So for example, if I was working on some development and there was a bug that I needed to fix, I could create a bug fix branch. So now I'd have 2 pieces of independent development work being taken place alongside each other. And it's best practice to never work directly on the master branch itself. So after the introduction, there's a page about actually working on a branch. So there's basic branching commands, so how to create a branch, how to switch between them, and also a practical example of this. Then after that, another interactive visualization to sum up the practical example, and then an exercise and solution and a tip. With branching comes merging. So when we have branches, we can merge them together. Say if we want to bring people's work together to productionize something, for example. So this page goes into how to merge two branches locally. So there is a working example and an interactive workflow to reinforce the example. Again, there's an exercise and tips box, and then at the end of this page, there's an extra interactive visualization just to reinforce and give more context to the idea of merging. Then finally, the last page goes into merge conflicts. So it gives a practical example of how to resolve a merge conflict locally, and then has an exercise which essentially creates an artificially creates a merge conflict for the user to then solve. So that's a quick demonstration of the app itself. And now I'm actually going to go into the code behind it and techniques that I used when creating the app. So when I created this app, I wanted to package it up in an R package. And to do this, you can use different techniques, and one technique is using the Golem package. So this is an opinionated framework for building production-grade Shiny applications. Essentially, it gives you a backbone framework and lots of useful functions to help you when creating a Shiny app as a package. So my directory for this package looks something like this. So we have an R directory, which contains the UI and the server files, so all the code for the app. The description file, so this contains things like imports, so Shiny Dashboard and ShinyJS, which are packages that I've used. And we have the namespace, so here there's only one exported function of this package, and that's the run app function, which launches the app. So if we just open up that R directory, it's got a number of files. So we have the app server and app UI files. So these actually provide a backbone structure for the UI in the server. So the way I have set up my files for the app is using something called modularization. Essentially, it breaks up the code into smaller modules, like functions, which can then be called. So the way I've set it up is that each page of my app has its own module, and within that, its own module, UI module and server module. So any of these files here that have mod in front of them contain the module UI and server components for that page. And then we have the run_app function, which is the exported function from the package. So I'm just going to move over to RStudio, and we can actually take a look at these files in more detail. So I'm going to open up the R directory, and first I'm just going to open up the app UI, app server, and run_app. So this file, the app UI, is a backbone structure for the UI. So here I'm creating a dashboard using Shiny Dashboard. So I have my dashboard header. I have all of the tabs or pages that I want to click on. I have some code to set up my bottom navigation bar. And then this code here defines the pages for and the relevant tabs. So for example, if we look at the setup page, this is referring to the setup tab. And this function here is my module that defines the page for the setup page. So within this module is all the code that lays out the content and the materials for that section. Similarly, in the server, I have some code which is used for the bottom navigation bar. And then at the bottom, I have all of my server modules. So here I have my server function for the setup page. And then in the run app file, this takes the UI in the server and launches the app. So if I have a look at my mod_setup page file, you can see that first we're creating a UI module function. So here I'm defining my boxes in the page with my content. So there's a little introduction, installing Git Bash, downloading Git Bash, etc. And then we have some image outputs. So this is where I define the specific UI content for that page. And then at the bottom of the script, I have the relevant server. So here is where I'm actually rendering those images in the page. So if I just go back to the app itself and open up the setup page, we can see we have these boxes with these images being rendered. So in terms of using Golem and actually structuring the package, I've used modularization to do this, and it's really easy to do. Golem, there is a function called, if I just cancel that, add module. And this works in a similar way to the user.r function from useThis, if you're familiar with that. Essentially, I can give it the name of the page. So I could say setup page, and this will create a module file in my R directory with a template or framework all set up. So I don't need to worry about how to actually form the module itself. I'll just go back to the presentation. I just want to go through a couple of packages that I used actually coding my app. So one package is the ShinyJS package. So this allows you to improve your app without needing to know JavaScript. So the way it works is that you call the function use ShinyJS somewhere in your UI, and then you have access to the functionality in other parts of your UI. So for example, I've used it to enable and disable action buttons. So launching the app again and going to the basic Git workflow page, you can see that at the start, the previous button has been disabled, and then it's enabled when I've moved on in the workflow, so I can actually go back. But right at the start, this button is disabled. So to do this, I can use the functions enable and disable. So here, this if statement takes some condition, for example, a button has been clicked, and it will either enable or disable that button. An equivalent way of writing this is using the function toggle state. So that essentially takes the if statement and just makes it one line of code. The sort of caveat with that is that toggle state, the name of the function isn't very clear, as opposed to the names of the functions enable and disable. And then in a similar way, we can hide and show buttons. So if I open up the app again and go to the start of the app, you can see that I don't have a previous button on my bottom navigation bar, so that's hidden. And it appears when I start moving through the pages. So I've done this using ShinyJS. So in a very similar way, I can use the functions show and hide. And this if statement has an equivalent function even, called toggle. Finally, ShinyJS can also be used to actually run your own custom JavaScript. So there's a function called RunJS where you can supply it your own JavaScript and it will apply it to your app. So I use this to allow the page to scroll up to the top when you go to a next page. So that's expected behavior with an app. If you click next page, the next page will start at the top of the screen. So this line of JavaScript essentially scrolls up to the top of the page. So that's where I've used that in the app. I'll just go back to RStudio. So I've currently. There we go. So yeah, so this is our studio. And so we've seen the modularization and the use of ShinyJS throughout, and also Shiny dashboard in the app UI to actually create this dashboard. I'm coming out of the Git Shiny package. I just want to show some of the example apps, so the smaller apps within the project as well. So there's 3 different apps. Close these files. So the first app is called Bottom Navigation. So this is a small app which just demonstrates how to involve a bottom navigation bar in your dashboard and how to have a button that moves between the pages of the dashboard. So to actually create this bottom navigation bar, I've used some code written by Natali, who is actually the author of the ShinyJS package. So if I go to his GitHub, he has a repository called Shiny Tips and Tricks for improving your apps. So there's loads of different folders for lots of different tips, tricks, common problems with code that you can use as open source with an MIT license. So you can use it, and as long as you copyright them in, and you can kind of play around with those. They're really useful. So this code allows you to create that bottom navigation bar. And then here we have code that creates a dashboard with 3 pages that have on each page a different plot. And in the server, we have code that switches between the pages when the button is clicked. So if I just run this app to show you what it looks like. So we just have these 3 pages, nothing sort of special going on. It's just a plot output. And then we have this bottom navigation bar with a next button. So I can click this button and it will move between the pages like so. And then at the end, it actually hides the button because there's no next button to go to. And also we can click any of these pages and the button will appear. Also, the actual label of the button changes as well, depending on which page you're on. So this code kind of is a small example, but trying to sort of encompass that functionality of the larger app. So we also have hide button. So this is just an example of how to hide a button once it's clicked. So if I run this app, it's very simple. There's a click me button, and when that's clicked, the button is hidden and we get a plot. And then finally, there's this modularization.r file, and this creates a quite simple sort of just a Shiny app, but it uses modularization. So here we have a UI module and a server module. And then the main UI and server just call those 2 modules. So this is a sort of small example to try and demonstrate how the server code actually works. So it can run this and it gives a app where when I click the button, it tells me how many times this button has been clicked. So one final thing I wanted to show you is this. So there are a number of Shiny extensions which you can use in your Shiny apps. So Shiny Widgets provides custom widgets. Shiny Alert can create pop-up messages. We also have Shiny Test, which allows you to create automated testing for your apps. And there's also a number of packages out there that have specific functionality to be able to be used within Shiny apps. For example, Plotly and Leaflet. They are packages in R that create interactive plots and maps, and they have specific functionality so they can be easily integrated within a Shiny application. And there are many more out there. So that is the end of the presentation. So does anyone have any questions?
Thank you, Elizabeth. That was really good. We've been so lucky to have Elizabeth as a professional placement student at Mango, and she's just been amazing. Like the amount of presentations and workshops you've done is incredible. So we're definitely going to miss you when you go.
I'll definitely miss it.
So we had a question from Diraj. In a Golang-based Shiny app, where would all the functions in global R reside?
So do you mean functions that, if I share my screen, I might be able to reshare. So do you mean, for example, I have in my R directory a function called navbar page inputs. So this is a function that creates the bottom navigation bar, which I call. So it's not a module, it's just a sort of a normal R, like an R function. Is that kind of thing you mean?
We'll give him. We've got 10 seconds for him to for the delay for him to reply. Catalin asks, "Congratulations, Elizabeth! Fantastic work. Is the app available?"
Yes, so it's available on the GitHub page, which I can send a link out for. I don't know what the best way of sending that is, Laura.
You can pop it in the chat, and then I can also email out to everyone. Alex also asked for the GitHub repo as well.
Cool, to send that in the.
Yeah, if you pop it in the chat, everyone should be able to see that. Cool, thank you. Susan Fox says, "This looks amazing, thank you. How long did it take to put together, and what was the biggest challenge?"
So in terms of time, I build it sort of in my own time at the weekends, and so sort of spread out over, I'd say, a few months, maybe kind of just sort of here and there working on it. It initially started out as a sort of exercise for me learning Golang. So I was interested in learning about Shiny. So I went in and sort of wanted to learn about Golang and Shiny apps and all of that stuff. So it kind of grew as I learned more and then kind of envisioned what I wanted to look like. I kind of think the biggest challenges were sort of little things that I wasn't expecting to come up as issues. So one of them, which I mentioned in the presentation, was how when you go to a next page, the page doesn't scroll up to the top of the screen. So I'm not very familiar with JavaScript, so that was something that kind of stumped me a bit. So I had to go away and try and work out how that works, and also kind of read JavaScript and try and get familiar with that. Yeah. And also part of the app as well was learning Git at the same time. So I was using Git to create the app and also learning about it and making sure that I was sort of portraying the correct best practices and making sure that the content was good for the app as well. So I got some colleagues to user test the app and go through the content as well.
In addition to Diraj's question, he said, so all of the functions would be separate R files in the R folder, and then Conrad has kind of answered him saying, since Golang Shiny apps are regular R packages, you can separate global declarations into as many files as you wish. There's no need for dedicated global R file, but they can all be in separate files, but they don't need to be. So I think that's kind of answered. I'll pop that there. Kamarul asks, which is better, Shiny apps or Flex dashboard?
I don't have much experience with Flex dashboard. Am I right in thinking that, if I am right in thinking that they are used more with R Markdown, then I'm not too sure in terms of, I guess it depends on how you're using it. So yeah, I think it just depends on the context. I'm not very familiar with Flex dashboard though.
I'll give it a minute. If anyone else has any questions, feel free to pop them in the Q&A section. We're just waiting for Mateo to join us. She should be here at 5 o'clock. Tell us a bit more. What are you going back to university to finish studying then, Elizabeth?
I'll stop sharing. I'm finishing off my degree in maths and statistics. So most of my modules are in statistics, things like time series and sort of applied statistics. A lot of the applied units involve R actually in the courseworks and things.
Cool.
And then a couple of computer science modules, so a bit more like programming with different programming languages.
Awesome. Let me just see what's going on in the chat. Everyone's just said thank you. Great presentation. Cool. All right. Thank you very much, Elizabeth. Much appreciated. I will take you off the stage. Cool. We are just waiting on Mateo to join us. So what we'll do while we wait for her to come along, let's just have a couple of minutes break. So feel free to go grab a drink or whatever. And we'll be back in a couple of minutes time, hopefully with Mateo's presentation. It's cool. Thank you very much, everyone. We'll be back in a couple of minutes. Hi, everyone. Thank you so much for your patience. I'm just waiting for Omotea to get back to me. She did say she would be here at 5 o'clock. So hopefully she's okay. I'm just dropping her another email to make sure that she can get online with us. So thank you so much for bearing with us. I mean, if anyone would like to do a random spur of the moment presentation on what they're doing in art, that would be great. But yeah, thank you. I'll keep messaging her. Hopefully she can join us shortly. If not, I'll wrap it up. I'll give it till 10 past. And if she's not here, then we'll wrap it up for tonight. But thank you so much for waiting. Thanks, guys. Thank you, Ryan, so much for suggesting that. I think what we'll do is we'll call it a night for now, just because we're getting a bit later on than we probably would have planned for. Thank you so much, Ryan. That's really, really kind. Hopefully Omotea is okay. She literally emailed me just before we started saying that she would be here at 5 o'clock. So hopefully she's okay. I'll check in with her and make sure everything's fine. The next LondonR, Kevin, I haven't got anything booked in for now. So where are we? We're in July. So in terms of what I'm doing, I've got Earl, so that's kind of taking up my time organizational wise. So I think post-September, I'm going to look at doing another LondonR, maybe in person. We'll see how things are in London and we'll see what kind of people's opinions are, but we'll definitely do something online after September, I think. So we'll see how that goes. We'll get the recording of this up tomorrow. And yeah, I'll share that with all of you. Thank you so much, everyone, for joining us. I mean, I'm surprised that it took over a year for someone not to show up at the right time. We've been super duper fortunate with everyone so far. So yeah, thank you very much for joining us, everybody. And I will let you know when the next meetup will be. and share the recording with you tomorrow. So yeah, thanks again, Paulito, and thanks again, Elizabeth. Cheers, everybody. Have a good night. I see that there's a hand raised. Was that on purpose? Would you like to say something, Mark Davies? You can pop it in the chat. If it was an accident, don't worry. Cool. All right, I will end things now. Cheers. Thanks a lot.